Alright, so what we have here is we have two boilers. They're both steam boilers. This showcases redundancy. Basically, it takes one boiler to heat the building. We have a second boiler as a backup, and also if the building's cold, so on a really cold day, we're doing a morning warm-up, this boiler will fire. Then this will be a secondary boiler that will also fire to be able to ramp up and get the building warmed up quicker. But one boiler is more than efficient to warm the building on a regular day. And also, if you're doing work on one boiler and you have it shut down, you can still have heat going to the building. This is a steam boiler that does low pressure steam. And low pressure steam is 15 pounds, 15 psi or less. On this gauge right here, this will let us know how much pressure is in the boiler. We typically go up to about 4 or 5 pounds max with this boiler. In a low pressure boiler, you do not need to have a stationary engineer present. In a high pressure boiler, you would have to have a stationary engineer license, and the boiler would have to be monitored all the time while it's being operated, just to make sure that everything's running efficiently, because a high pressure steam boiler, if something goes wrong and it blows, the amount of damage that it can do, you want to make sure that you can minimize that and that doesn't happen. That's not to say that if a low pressure boiler blows, you won't have damage. It will do a lot of damage. So your low pressure steam goes out once this heats up to 212 degrees. That is the boiling point where it goes from liquid to steam. Now it's important to note that BTUs, British Thermal Unit, every degree that you go up before you hit 212, you're using 1 BTU to go up that degree. So if you go from 97 degrees to 98 degrees, that's 1 BTU. Once you hit 212 degrees, it takes 970 BTUs to be able to make that final transition between liquid to steam. Okay, so there's a huge reaction going in there to be able to make that happen. With that being said, we get a call for heat. Our dampers back here, and it's a little difficult to see with the grate over them, but those open up and that lets in outside air. That outside air comes in because we need that as makeup air for combustion. So we have a fire tube boiler here. It heats up. This pipe right here is for our flue gas. So our carbon monoxide that we create due to combustion is safely vented outside of the room. All right. Our dampers stay open while we're firing, letting in that makeup air that we're sucking out of this room. As this boiler heats up and it begins to make steam, it will push out through the pipe. As it pushes out through that pipe and goes through the building and condenses, our condensate will come back through this line into our makeup water tank. And our makeup water tank is for water lost, especially in an older system where you may have leaks in pipes and things like that. And that's water that gets pumped back into the boiler system in order to keep making steam. Now, a boiler that's at 212 degrees, you do not want to pump in, 60 degree water. You'll crack the boiler. You face that potential. Okay, so what you want to do is you want to be able to at least temper that water by bringing back the condensate, which might be at 140 degrees, 180 degrees. It goes into the city water that we fill this with, and it tempers it enough so that when these pumps down here pump it into these two boilers, we're pumping in hot water. So a boiler that's very hot, think of it as you do dishes, you open up the dishwasher, you pull out a glass while it's still hot, and you put ice cold water into it and the bottom of the glass cracks out. It's the same difference as if you dumped in cold water into a boiler, you'll crack the boiler. And if you crack the boiler, you've essentially ruined the boiler. It's not going to be any good anymore. And we don't want to cause that, so we make sure that as we're pumping this makeup water in here, it's tempered. All right, so We talked about repairs before. If you shut a boiler down and it cools all the way down, the last thing that you want to do is add too cold of water if it's still pretty hot. It might have cooled down to 160 degrees, but you still don't want to put ice cold water into it. You want to make sure that you either let it cool completely down and add water, or you make sure that your water is still hot enough and tempered. Just like if I put my hand all the way on this tank, it's very, very hot right now. Could be 160, could be 180 degree water. All right. So as that proceeds, again, we have redundancy here. So we have a 2-boiler system, but they also share a pipe. Okay. And that pipe they share is letting that water rotate back and forth. So if this boiler is firing and this boiler is not, it's still sharing water from this boiler, which means this boiler is coming up to temp where it may not be at 212 degrees, but it's still warm enough where if it does have to fire on, it's not going to take as long for it to be able to start producing steam. And down here it says boiler blowdown, and typically you'll want to blow down a boiler a few times a week. Some people might recommend once a day. And what that is you open up a valve and you drain out some of the water because you get, garbage from the pipes. You get different things where you want to get some of that out of the system so that you don't get scale building up in your boiler. You can see over here on the sight glass that it's actually a green looking liquid, and the particular chemical that's added to this boiler to help with scale is colored so that you know that the chemical is in there. Sometimes you don't see that, but this one happens to have that, and the sight glass lets you know that there's water in this boiler. As we talk about boilers more, we'll get into 1-pipe and 2-pipe systems. This is considered a 2-pipe system. On a 1-pipe system, what that means is your steam goes out and your condensate comes back through the exact same pipe. In a 2-pipe system, steam goes out, condensate comes back from a secondary pipe.